Hi everyone. In today's session, we are going to discuss about IP addressing. So as we discussed in previous session about MAC address, so we know MAC address is physical address which is present on the NIC card, layer 2 address, but only MAC address is not sufficient for this communication. So we have to assign layer 3 address to the NIC card, which is called their internet protocol address. So this protocol means set of rule for communication, because without protocol communication is not possible. So that's why we have to assign IP address to each device here, which is present in the network here. So that's why NIC card should have both address. Physical address means MAC address and logical address here. So IP address is called as a logical address because we can change this address as per our requirement here, which is not by default assigned here. MAC address you will get by default on NIC card here, either it is wired or wireless, but we have to assign this internet protocol address, which is logical address and layer 3 address. Then by using this IP address here, we can access internet, in particular local area network. Then IP address is also used to carry the user data from one device to another device. So we know if you want to send a data from source to destination, so these devices having this MAC address, which is present on this NIC card. So MAC address is the physical identity of this particular device here. So that's why when the sender will send a data on this actual address, MAC address here, by using IP address, because their protocol is required here. So that's why this is IP address, internet protocol address. So IP address is also used to carry the user data from one device to another device. Then by using this IP address, we can access your internet also in the local area network. And if you want to identify the device in particular network, so by using its IP address, you can also identify this device here. Like suppose we have this WAN connectivity, and in this WAN connectivity, if you want to identify this device here, actual location here, so that's why by using its logical address, we can identify the device here. Then suppose if you want to identify this device here, so you can also identify this device by using its logical address, internet protocol address here. So that's why this IP address is also used to carry the user data from one device to another device here within the network or outside the network. But if the network is different, in that case we have to configure a routing also. So that's why for each device here, like we have this router, switch, PC, whatever we have these devices in the LAN or WAN here. So we have to assign internet protocol address on the NIC card here. So by using this both address here, physical address and logical address, L2 and L3, communication is possible in between these devices here. So that's why nowadays in this IP address here, there are two versions. Internet protocol version 4 is IPv4, and the second version is IPv6, internet protocol version 6. So there is no version like version 1, version 2, version 3, version 5. Okay. Because of this 32-bit, we have version 4 here. So IPv4 address is 32-bit address, and we know bit nothing but a combination of 0 and 1, which is binary language here. Then IPv6 128-bit address. That's why because of this 128-bit, you will get more number of IP in version 6 here. So that's why IPv6 is the extension of IPv4 here. So we have these two version here, version 4 and version 6. So first here we will cover this IPv4 here, like representation of IPv4, classification in IPv4 here, version 4. So this IPv4 is 32-bit. So that's why if you want to represent this IP address here, so in binary, we have this representation. So we can write any 32-bit, which will be the combination of 0 and 1, because device will understand only this machine language, binary language, in the form of 0 and 1. But for human understanding, we have this decimal form here and hexadecimal. But IPv4, it is represented in decimal form here. So we can write any 32-bit here because it can be any possible combination in the form of 0 and 1. So that's why for binary base 2, so you will get total IP address in version 4, 2 raised to the power 32 here. So we have this total 4.3 billion IP address in version 4 here. Actually, these are the limited IP address here. Only 4.3 billion because of this 32-bit. So it can be any 32-bit here. So we have this one example of IPv4 address in binary form here. So this IPv4 address is divided into 4 octet here. So these total 32 bit are divided into 4 octets. So that's why 1 octet is equals to 8 bit of binary here. So we have this first octet, second, third, and fourth here. And each octet is separated by this dot symbol in IPv4 here. But we know this is for computer understanding here, this binary language. So suppose we have this 32 bits here. So first octet 116 times 0, then dot symbol here, then second octet, third octet, and fourth octet. So here we have to convert this binary to decimal, because actually we have to assign decimal form of this IPv4 to the device here. So that's why we have this first octet here 116 times 0. This is binary. But for human understanding, we have to convert this each octet in decimal form here. So that's why we have to use their power table. So as we discussed in MAC address power table for 4-bit, but right now in this IP address you will get power table for 8-bit here. And for binary base 2, so that's why 2 raised to the power 0, first combination means, because they are total 8 bits here. So this is the first bit, then 2 raised to the power 1, 2 raised to the power 2, 3 up to 2 raised to the power 7. So 0 to 7 means total 8 bit here. And these are the power table value means decimal value here. So 2 raised to the power 0 means 1, because any number raised to the power 0 means 1. So 2 raised to the power 1, 2, then 2 to the power 2, 4. So actually this will be double here, 1, 2, 4, 8, 16, 32, 64, 128. Then by this power table, we can easily convert, because inside this device, there is transistor, logic gates also, in which one represent flow of electricity, means on, means high bit here. Then 0 represent no flow of electricity of low bit. So that's why in this conversion also, 1 is for count and 0 is for no count. So we have this first octet here. So we have to put all this bit, 8 bit in this power table as it is. So we have this bit here 116 times 0. So we know 1 is for count. So we have to check this 1 value here, 1 bit. So we have this 1 here, and for this one, power table value 128. Then again we have this 1 here, power table decimal value 64. And 0 for no count here, because all these are the 0. So no need to count this decimal value here. So that's why for this binary, decimal value will be 128 plus 64, means 192. And this 192 for human understanding here, because decimal value. So that's why we have this first octet here in decimal form here, 192. Same we have to calculate second octet also, okay, in decimal value. So we have this second octet here, 8 bit, 10 10 00 10. So again we have to put this all 8 bit in this power table as it is here. Then you have to check here 1 bit, because 1 is for count. So that's why we have this second octet here in this binary. So we have to put all this 8 bit here. So the first bit is 1 0, then again 1 0 0 0 1 0. So if you check here this 1 value, so we have this 1 bit here, because 1 is for count. Again we have this 1 and this one. So for this one here, power table value 128. So this is for count. Then again we have this one 32. Then we have to count here 2 here. So that's for 128 plus 32 plus 2 means 162. So this 162 decimal value for second octet here. So that's where 128 plus 32, which is 160, 160 plus 2, 162. So we know in decimal here, you will get these numbers here 0 to 9, because we can easily understand these numbers here. Okay. So that's what decimal is for human understanding and binary is for computer understanding. So we have to assign this decimal value to the device here. And inside this device, this is the conversion here. And this conversion is called as here binary to decimal conversion here. So that's why when you assign IP address to the device here in this decimal form, so device automatically will convert into binary here, because we know device will understand only the language of 0 and 1 here. So that's why we have this second octet, first octet 192, second octet 162, and in this third octet here we have this 1 1. and all bits are 0. So that's why decimal value will be 3. Then again we have this last binary here, only 1 here, all zeros here. So that's why only 1 here. So decimal form of this IP address is 192.162.3.1 here. So that's why we have to assign this IPv4 address to the device. Okay. No need to assign here binary, okay, because here we have to assign decimal form. And when you assign this decimal value 4 octet to this device here, but device will not understand this number here. Device will convert into binary. So device will understand this machine language here, binary language in 32 bits here, which are divided into 4 octet. So that's why we have this binary to decimal conversion. Same you can also convert decimal to binary also by using this power table here. So we have this decimal number here. We can take any decimal number. So suppose we have this decimal value here 37. So if you want to write this 37 into binary here, you have to check this power table value. So total addition should be 37. So that's why we cannot take here 128. So we have to put here 0. Again 0. So we can take here 32. So that's why 1. So 32 plus 4 plus 1. So we have to write here 1 here. Then remaining bit will be 0. So that's why this will be the conversion, decimal to binary. Because here we have this total 37 here, this addition. So this is binary form here. So we can convert any number here, decimal to binary here. Like suppose we have this 208, suppose 208. So if you want to write this 208 in 8-bit decimal value, so we have to write here 128, 1. Then 128 plus 64, 192. Then in this 192 here, again if you add here 32, so this will be greater than 208 because 224 here, so you cannot add here 32. So that's why 0. So this is already 192. Then in this 192, if you add here 16, so you will get here 208. And remaining bit will be 0 here. So that's why we have this conversion here. Binary to decimal, decimal to binary here. So 128 plus 64, okay. 192 plus 16, 208 here. So that's why we have this representation here. But in this IP address form here, you cannot write any number here because of this 8-bit. There is range here. So if you want to write this 8-bit here, in each octet, so we have this 8-bit. So for binary base 2, so total possible combination will be 2 raised to the power 8, 256 combination in each octet. So first combination you can write here, all 8-bit will be 0. Then last combination will be all 8-bit will be 1 here. So that's why total combination you will get here 0 to 255, means 256 actually. So that's why we have these numbers here. In this IPv4, we cannot write any number. We have to write the number only in between 0 and 254, means 0 to 254 as well. So that's why because of this 8-bit, total 256 combination, which is 0 to 255. So first combination here, all 8 bits are 0 here. This is the first combination. If you put here all 8 bits 0. Then for this one here, you have to put 7 times 0, then 1, decimal value 1. Then again we have this 2, then you will get here 3. So for this 3, we have to add here 2 plus 1, all zeros here. So that's why you will get here 3, 4, 5, 6 up to 255. So when you put here all 8-bit 1 here, this is the last possible combination in IPv4 here. This is the first combination, all 8-bit 0, and this is the last combination here. So that's why in IPv4 here we have this range here. So minimum number we can write here 0 in version 4, and maximum number we can write here 255. In each octet here, this is the range for each octet. And we know we have this total 4 octet here. So that's why first IP before address will be 0.0.0.0 because in each octet the first number will be 0. So this is the first IP. Then the last IP address here 255.255.255.255. And these are the total 4.3 billion IP address here because of this 32-bit here, because it can be any combination. So when you convert this IP address, so you will get here first IP, all 32-bit will be 0 because first octet, all 8-bit 0 here, means all 32-bit. Same when you convert the last IP, you will get all 32-bit will be 1 here. So that's why in between this IP means total IP 4.3 billion. And these IP addresses are classified into 5 class here, and there is classification. These are divided into 5 class. So that's why you will get class A IP address, class B, C, D, and E. 5 class here in version 4. And we have to calculate the range of each class here. But if you want to assign the IP address in local area network, wide area network, so you have to use only A, B, and C class here. Okay? So we have this IP addressing here. So IP address, we know this is logical address. Then IP address is network layer address, which works on network layer of OSI model, which is L3 address here. Then IP address has 2 versions here, version 4 and version 6, 32-bit and 128. Okay. So we are talking about version 4 here, 32-bit. So bit is represented by 0 or 1, that is binary, machine language. So it can be any combination. Suppose we have this total 32-bit, which are divided into 4 octet, and each octet is separated by dot symbol. But this is for computer understanding, 0 and 1 language, binary. So for human understanding, by using this power table, we can convert this each octet into decimal. So for the first octet, you will get here 85, then 5, 191, and 1. So this will be the decimal form of this IP address here. And we have to assign this decimal value to the device here, and device will convert into binary. So that's why we have this range here. So taking example for the any octet here, first, second, like this, because in each octet there are 8-bit, and it can be any possible combination of 8-bit. So you will get a total 256 combination, and this 256 combination means 0 to 255. So that's why we have this range for IPv4 here, total IP address here, and these are classified into 5 classes here. So that's why there is classification in IPv4. So we have this conversion again, binary to decimal conversion. So we have this binary here 116 times 0 means 192. Then we have this second binary here. We have to check here one value. So that's for 1, and again this one here. So this will be 10. 8 plus 2. Then what will be the decimal value for this third binary here? 10 10 1 0 0 0. Yes. What will be the decimal value?
168.
168. 168, because they are 128 plus 32 plus 8. So 32 plus 8 here 40. 40 plus 128. So 168. Then what will be the decimal value for the next binary here?
178.
78 or 72?
178.
172.
172, because this one is up to this one, you can see already we have this 168 here, 10101. So up to this binary bit 168. Just we have this one here, and this one is 4. So that's why 168 plus 4, 172. Then the last binary here we have this single bit here 1. So 16 here. Same here decimal to binary also. So we have this 18, and 18 means 16 plus 2. So that's why 0 0 0. Then here 1 and 1. Remaining all bit will be 0. Then here 152. So 152 means 128 plus 16 plus 8. So 16 plus 8, 24. 24 plus 128. Okay, 152. Remaining all binary bit will be 0 here. Then for this decimal number 200 here. So 200 means 128 plus 64, 192. And 192 plus 8 here. So that's why 1 1 0 0 1 0 0 0. Then what will be the binary for this decimal value 15 here?
Last four bits will be 1111. Rest all
One, correct.
00.
So first 4 bit will be 0, 4 bit, and the last 4 bit will be 1 because 8, 4, 2, 1, 15. Okay. Then for this 240, what will be the binary?
One 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 zero 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 zero.
Correct. So here first 4 bit will be 1 and the last 4 bit will be 0 because 128 plus 64, 192, 192 plus 32 plus 16, 240 here. Okay. And remaining bit will be 0. And we know if all 8 bits are 1, this is the last possible combination, which is 255. Then we have this classification here. So IP address classification. IP address are divided into 5 classes here. Okay. So in this local area network and for wide area network, we have to use only these 3 classes here. Class A, B and CIP. We cannot use here class D or class E to any device here. Because class D IP address, this is already reserved for multicasting here. And multicasting means sending the data from single source to multiple receiver at a time. It means one to many communication. This is called as multicasting. So class D is already reserved here. Then class E IP address, this is also reserved for research and development purpose. So we have this organization here, INA. So actually INA means Internet Assigned Number Authority. So this organization has already reserved this IP address. With this Internet Assigned Number Authority, INA organization is responsible for providing and controlling the IP address here. So suppose we have this one local area network and wide area network. So in this one, we can use only class A IP address to this device, class B or class E. Any class we can assign, but you cannot assign here class D or class E. In this local area network, for router, switch, whatever we have this device, as well as for WAN also, for this router interface, we have to use only this class here, either ABC. We cannot use here class D or class E here, because this multicasting means in IPv4 here, we have this address type here. Okay. 3 address type here. So that's why you will get here unicast, multicast and broadcast here. These are the address type in version 4. So here unicast means one-to-one communication. So one-to-one communication means one sender and one receiver. This is called as a unicast. So if one device is sending data to one receiver, source and destination. So this type of address type here, unicast here, okay, by using class A, B, C. Okay. So here communication possible, unicast. Then here multicast here, class D here, class D. So class D is already reserved for multicasting and which is called as one-to-many communication. Means one sender and many receiver. So that's why if one sender is sending data to many receiver at a time, so this type of communication is called as their multicasting. So that's why suppose we have this one server here, but actually in this multicast here, we have to create a multicast group. So suppose we have this one server and these are the device here, PC 1, 2, 3 like this. So in this multicast here, we have to create a group here, multicast group. So multicast group means, suppose if I select here these devices in multicast group here, PC1, PC2, PC3, this device. So if these 3 devices, number of devices we can select. Okay? If these devices are in multicast group, so that's why only these devices will receive the data at a time, okay, from this server here. This is called as a multicast here. One-to-many communication. So this server will send your multicast traffic to only these devices which are present in multicast group here by using multicast address here. Okay? So that's why class D is used here. This is multicast group. So suppose here if PC4 is not present in the multicast group, so it means this server will not send any multicast traffic, means data to the PC4 here. Okay? So this multicast example means here, in this device here, you will get a link here. So you have to click on this link and you will be the part of this multicast group here. Like suppose here, for example, we are taking this session here. Okay. So you will get a link to join the session. So we have this different user 1, 2, 3. Okay. So all user will get a link here, but only those user will join the session who will click on this link here. Okay. Suppose these 3 user. So these 3 user will get a multicast traffic here data. Okay. If PC4, this user number 4, okay, which is not a part of multicast group. Okay. Suppose same link here, but this device is not connected. It means this device is not a group of multicast here. So this device will not get here multicast data here from this server. Okay. So in that case here, we have to use here class D here, but not for the device here, for this multicast purpose here. And for routing protocol also, multicast addresses are already reserved here for each dynamic routing protocol. So for the device, actually we cannot assign because we have this class D IP. And we know here different types of dynamic routing protocol here, like we have this RIP protocol, dynamic routing protocol for communication purpose after WAN connectivity. Then OSPF protocol. Then we have this EIGRP, different dynamic routing protocol. So for this dynamic routing protocol, you will get here multicast address here. So if you want to send a data from this Chennai to Hyderabad, so these are the path here A and B. It can be number of path. But when you configure dynamic routing protocol, suppose here for example RIP protocol, on each router here, after this WAN connectivity, wide area network. Okay. So when you configure this protocol, so this Chennai branch router will send here multicast traffic here, means actually data here by the multicast address, which is called as an update. Same Hyderabad branch router will also send here multicast update to the its neighbor Chennai and Bangalore. Same here Bangalore to Hyderabad, Bangalore to Chennai. So each router will use their multicast address of this particular protocol here. Suppose if RIP protocol is configured on each router here, so that's why each router will use this multicast address automatically, because this is already reserved here for RIP 224.0.0.9. This multicast address is reserved here. Then if you configure suppose OSPF protocol, so same this router will send here update. Update means information. Okay. So by using this multicast address here, so for OSPF 224.0.0.5, but actually two multicast address 0.6 also, okay, in OSPF, but generally 0.5 here. Then here EIGRP 224.0.0.10. So all these are the multicast address from class D. So that's why we cannot assign this class D IP address to any devices. This is already reserved by this organization INA for different routing protocol, for different purpose here, multicast for routing protocol like this. So we cannot use here class D. Then the third address type you will get here broadcast. So broadcast means one sender, all receiver, one to all communication. So that's why this is called as a broadcasting. And for broadcast purpose here, broadcast address is used here. And broadcast address means in each class here, if you take here class A IP address, class B, class C, any network here. Okay. So last IP address is called as a broadcast address. This is actually last IP. Okay. So in next session, we will discuss how to calculate network address and the broadcast address. Network address is the first IP address in each class and broadcast address is the last IP. So that's why our broadcast address is used for the broadcasting purpose here. And broadcasting means suppose live broadcasting here. We have this one server here. So if this server is sending broadcast traffic to all devices here, this is live broadcasting. Okay. So that's why one sender, all receiver here, one to all communication. In that case, broadcast address are used here. So these are the address type here. But how we can identify like either the IP address is class A, class B, class C. So that's why, because we have only range here 0 to 255. So that's why we have to calculate the range of each class here, because this total IP address are divided into 5 classes. So that's why out of this number 0 to 255, this range. first we have to calculate the range of class A IP address. So to calculate the range here in IPv4, priority bit is used here. So that's why priority bit is used for IP address classification. And actually this priority bit is present only in the first octet of IP address because there are 4 octets. So it means priority bit is not present in second, third and fourth octet. This is present only in first octet of IP address. So that's why this is most significant bits from the first octet are selected for priority bit. So we have this priority bit here. So for class A IP, the priority bit is 0, which is present in the first octet. Then for class B, the priority bit 10. For class C, 110. Class D, 1110. Then for class E, 1111. So in binary, you can easily identify the class here for this IP address. Suppose we have this one IP address here in binary form. So suppose there 0, 1, 0, 0, 1, 1, 0, 1, any combination here, then 1, 0, whatever we have this bits here. So we have this first octet, then second octet, third octet and fourth octet here. So in this IP address here, you will get total 4 octet. But we know priority bit is present only in the first octet of IP address. This is the second octet, 8 bit, whatever is the 8 bit. Okay. Then third octet and the fourth octet. Okay. But so can you tell me which class of IP address is this? In binary, which class of IP? We have binary form here. So if you want to identify the class in binary, so you have to check here first octet. So in the first octet, if the first number is 0, first binary bit here, so it means this is actually priority bit here. 0. So which class of IP?
Class A.
Class A. Because here priority bit is 0. And we know priority bit is 0 for class A. So that's why in binary here, any IP address which start with this binary bit here, 0 here. So here we have this class A IP address because here priority bit 0. Then suppose if I write again binary form of IP address here, so we have this IP address here like 10, 11, then 00, then 01 dot 0010, whatever we have this binary form here. So which class of IP address?
Class B.
Class B, because we have this first octet and priority bit is present only in the first octet, right? So that's why we have this 10. And you can see if any IP address which start with the binary bit here 10, class B, only in first octet. Okay. Even if you put here 10 here, so it does not depend on the second octet. It can be any combination here, Suppose again we have this 1 0, this one. So these are not priority bit here. In third and fourth octet also. Priority bit is present only in the first octet of IP address. So that's why if any IP which starts with this binary bit here 1 0. So this is priority bit. It means class B IP address. Same, suppose we have this one IP address here 1 1 1. Yes. 1 1 1 0, then 0 0 1 0, then 0 0 1 1. So which class of IP?
Class C.
Class D. Because this is priority bit here 1 1 1 0 and 1 1 1 0 means for class D here. Only in the first octet here. Because in second, third and fourth octet there is no priority bit here. Same, suppose for class C here you will get this binary bit here 1 1 0 here. 3 bits here. Then it can be any bit here. In second, third and fourth octet here. So we have this 1 1 0. Then again 1 1. Whatever we have this bits here. Okay. So this is the first octet. So that's why 1 1 0 priority bit. First octet and class CIP. Same, we have this 1 1 1 1. Okay. So this is class EIP address. But this is already reserved for research and development purpose. So that's why in binary you can easily identify the class here, either class A, B, C like this, because of this priority bit here. But actually we have to calculate the range in decimal, because we have this decimal form here 0 to 255. So that's why here we have to calculate this range for decimal value. So first calculation for class A, because we know the total range is 0 to 255. So that's why for class A here we have this priority bit 0. And 0 is fixed bit in the first octet, because we have this first octet here. So that's why the first bit is 0, which is fixed. So this priority bit will not change here. This one is fixed here. Remaining 7 bit will change here. And because of this remaining 7 bit combination, can 7 bit here 0, then 1, 2, 3, 4, 5, 6 like this. Up to 0, 7 times 1 here, because this is the last possible combination. 7 times 0, 7 times 1. So that's why, or simply you can also convert this binary to decimal. You will get here 0. Then here 1, 2, 3, 4, 5, 6, 7 up to 127. Because of this priority bit. So 0 is fixed here, priority bit. And this priority bit is not present in second, third and fourth octet. So that's why in second, third and fourth octet you can write any number, because there is no priority bit. Okay? You can see this one is 0. You will get here 1 also, 0, 1, whatever will be the bits here. So that's why in this one we can write here number in between this range 0 to 255, any number, because there is no priority bit here. This is not a priority bit. Same in third octet here we can write any number 0 to 255. And in fourth octet also 0 to 255. But only in the first octet, because of this priority bit, we have this range here 0 to 127. So that's why if you check in the first octet, if the number is in between this range here 0 to 127, so class A IP address, because of this priority bit. Okay. So we know, so directly you can also calculate again. Suppose if I put here 1 here, so we know this all bit 1, 255. But we have this 0 here. Okay. So that's why here 255 minus, and this minus means this 0, no count, 128. So if you subtract here 128, you will get the last number 127. Or simply you have to count here 64 plus 32, 16, 8, 4, 2, 1. You will get here 127, last one. Because 128 is 0 bit here, this one. Okay. So no count. So that's why this is the priority bit here. So we have this range here for class A 0 to 127 in decimal form here. But actually in IP address form, so the first IP you will get here 0 dot, because of this priority bit here 0 dot 0 dot 0 dot 0. This is second, third and fourth octet. No priority bit here. So the first number will be 0, because we know in second, third and fourth octet it can be any number 0 to 255. No priority bit. But priority bit is present only in the first octet. So the number is 0. Then you will get here 1, 2, 3, 4, 5, 6 up to 127. It can be any number. So that's why only first octet will change here. You can identify the class by using only first octet because of this priority bit 0 to 127. And in second, third, and fourth octet, you can write the number in between 0 to 255. So that's why 0 to 127 range for class A. Same when you calculate the range for class B, because after 127 you will get the next range 128. So that's why class B range for class 128 here. For class B you will get the first number here 128 actually, because we have this priority bit here 10. So not 192. 192 for class C actually, not for B. Okay. So that's why here we have this priority bit 10. So this 10 bit, this will not change here. Priority bit here. Yes, can you hear me?
Yes, sir, you're audible.
So for class B here, we have this priority bit 10. So 10 will not change here because this is priority bit. fixed here. Then here we have this 1 0 priority bit. So because of this 1 0 here, the decimal number 128 is already fixed here, because 0 means no count and this 1 means 128. So that's why we have this decimal number 128. Then remaining 6 bit will change here. So 0, then 1, 2, 3, 4, 5 like this. So that's why 128 plus 0, 128 plus 1, 128 plus 2, 3 like this. Because 128 number is fixed. So that's why you will get this range here 128 to 191 in the first octet because of this priority bit. Because here 1 7 times 0 like this. But this is priority bit here 1 0. So that's why 128, 129, 130 up to last one here 191. This is the range for class B IP address. Because same here 255 minus. So this 0 means 64 here. So minus 64 you will get here 191. This is the last number. So in decimal we have this 120 and in IP address form here we have this IP address. So first type in class B 128.0.0.0. This is the first IP address here. Then here last IP here 191.255.255.255. Because we know only in the first octet we have this number. So it can be any number 128, 129 like this up to 131. And there is no priority bit in second, third and fourth octet. So 0 to 255. It can be any number here. So that's why we have this range for class B IP address 128 to 191. Then the next range for class C, because after 191 you will get here class C range here, which will start with the number 192. So that's why in this IP address these priority bits are used here. So we have this class A range 0 to 127. Then for class B 128 to 191. Then the next one for class C. So class C range 192 to 223, because there are 3 bits here 110, which is present in the first octet, priority bit here. So that's why this, because of this 110 3 bit, decimal number 192 is already fixed here 192. So remaining 5 bit will change here, because we have this 192. 192 means here 128 plus 64 192. Then here 0 1 2 3 4 5 like this. So 192 to 223, because same here 255 minus this 0 means here 32. So 255 minus 32 223. So we have this range for class C. The first IP address here 192.0.0.0 to 223.255.255.255. So this 192 to 223 because of the priority bit. Then after class C you will get a class D range, multicast address range, which will start with the number 224 here, because here priority bit here 1110 4 bit. So because of this 1110, decimal number 224 is already fixed here, because you can see 1110 means 128 plus 64 plus 32, 224, 3 bits here. So that's why again here 224 plus 0, 224 plus 1, 2, 3 like this. So that's why 224 to 239. This is the range for class D. And this class D range is used for multicasting purpose here, multicast here. Then after this one, class E range, last one, 240 to 255, because 255 is the last number. So this range is already reserved here. Priority bit 1111. So because of this priority bit here 1111, 240 decimal number is fixed here. This will not change, because first 4 bits are 1. Then last 4 bits 0. Because only last 4 bit will change here 0, 1, 2, 3 like this. 240 same. So 240 plus 0, 240 plus 1 like this. So we have this last IP address. 255, 255 this one. So this is actually class E IP address. So these total IP addresses are divided into 5 classes here. So right now in decimal also, you can easily identify the class here. So these total IP addresses are classified into 5 classes. Because we know this is the first IP address, class A IP. Then this last IP you can see 0 and 255. Class E. Then in between this one you will get class B, C and D range. Number of IP. So that's why this total IP address are divided into 5 classes here. And if you want to identify the class here, so we know in binary we can easily identify by using priority bit. But in decimal also we can easily identify the class here. So that's why the next one is identifying class here. So we have this range here for class A 0 to 127, class B 128 to 191 in first octet. Then class C 192 to 223, then class D and E here. Then the next one is identifying class here. So here, if you want to identify the class, so we have some IP address. So we have this first IP 10.1.100.1. So can you tell me which class of IP address?
Class A.
Class A. Because we have this range here. So for class A 0 to 127. Then you will get 128 to 191. Then 192 to 223. Then multicast address range 224 to 239. And the last one 240 to 255. So we have this first IP address here, which is 10.1.100.1. So we know priority bit is present only in the first octet in binary also. But you have to check this decimal number 10. So this first decimal number 10, this lies between this range here 0 to 127 because of the priority bit. So that's why class A IP address. Even when you convert this 10 into binary, you can see 0, 0, 0, 0. Then 1, 0, 1, 0, first octet. So you will get this priority bit here. And we know 0 means class A IP. Okay. And in decimal, 0 to 127. So we have this number 10 here. So class A IP address. Then the next one 192.1.1.1. Which class of IP?
Class C.
Class C, because they are 192 in the first octet here. And we know 192 means class C IP address here. And when you convert this 192 into binary also, you will get a priority bit. So as we discussed this first example here, IP address. So you can see in this IP address here, we have this 192 first octet. So we know this is class C IP address. And for class C, we have this priority bit 110. And this priority bit is present in the first octet. So if you check here, you will get this 110 only in the first octet here. Even if you put here 110, suppose any number here, again we have this 110, but these are not priority bit. Not in second, third, and fourth octet. Priority bit is present only in the first octet. So that's why we have this range 192 to 223 here. So 192 means class C IP address. Then the next IP address here 224.0.0.10. Which class of IP?
Class D.
Class D, because they are 224. And we know this 224 to 239, this range is already reserved for multicast purpose here. For different routing protocol also, you will get your multicast address here. So that's why we cannot assign this range here, because you can see we have this 224. 224, and this 224.0.0.10 actually this is for EIGRP from this class D. So that's why we have this multicast address here. Then the next IP address here 120.200.1.1. Which class?
Class A.
Class A, because they are 120, and we know class A range is 0 to 127, and we have this 120. It means class A IP address. You can see in the first octet here we have this 120. Same if you write here 120 here, you can see 120. Okay? Whatever the IP. So 120 also lies between this range here. So that's why class A IP address. Then the next one 150.17.2.200. Which class of IP?
Class B.
Class B. Because they are 150. So that's why 150 lies between this range here, second range. Correct. Class B. Then the last IP address here. 17.1.256.1. Which class of IP?
Class A.
Class A. Yes, other. Which class of IP address? Last IP. Seventeen dot 1.256.1. So you can see actually this is not a class A IP address because this 17 is correct here. Okay, this lies between this range. But you have to check remaining octet also, not only first octet. Because of the first octet, we can identify the class. But you can see in third octet here, we have this decimal number 256, which is not possible because of this 8-bit. So that's why as we calculated this range here, okay, 0 to 255, minimum number we can write here 0, maximum number we can write here 255 in IPv4 address here. Because you can see, suppose if you want to write here 256, so in 8-bit you cannot write because these are the all 8 bits here 111. After this one you cannot write in 8-bit. So that's why if it is any number in IPv4 which is greater than 255, any number like 256, 300, 400, whatever we have this number greater than 255, this IP address is called as an invalid IP. This is not a class A IP address. Invalid IP. If you put here suppose 255 here, this decimal number, then in that case this will be the class A IP, equal to or less than 255. But if it is greater than 255 number, so this number is not possible in decimal because of the 8-bit. Because if you want to write 256 in binary 8-bit, you cannot write. Maximum number you can write here 255 only. So that's why invalid IP address here. So you can easily identify the class here, class A, B, C like this. So that's why this is called as identification of class here. So the last IP address here, because of this 256, invalid IP. Okay. So in this IP address here, this is representation, conversion, range calculation, and identification. But if you want to assign your class A IP address to any device, so we know we have this range 0 to 127. But here you cannot assign the IP address which start with the number 0. Similarly, you cannot assign the IP address which start with the number 127 here. Because this 0 IP and 127 IP, these are the reserved IP in class A. So suppose we have this one local area network, and if you want to assign here class A IP address, either in LAN or WAN also. So we have this total range 0 to 127. But this network is already reserved here, means we cannot use here 0.0.0.0. This is actually network ID. So that's why in first octet you cannot assign the 0 number. Like suppose we have this device, so you cannot assign it 0.1.2.4, any IP address which start with the number 0, because entire network is unknown here. Means this 0.0.0. This IP address here, all 32 bits are 0 here in the binary also. So that's why actually this is used in default routing. We know default routing is third type of IP routing. So if you want to access your internet, in that case this default routing is used here, which is used for unknown destination over the internet. If you don't know the destination here, so that's why this IP address is used as a default route in the configuration for unknown destination. So you cannot assign 0 IP to any device here, entire network here. Any IP which start with the number 0, you cannot assign to any devices in the network. Similarly, you cannot assign any IP which start with the number 127 here, any IP address here, because 127 network is already reserved to the operating system here for each device here. It means we have this actually network ID. This is one example here. But you will get here network ID here 127.0.0.0. This is the network ID here. So that's why any IP which starts with the number 127. This is actually called as a loopback address. And loopback address means this IP address is used for self-testing of a device. So self-testing means to test the NIC card. So that's why we can also use here this IP address. So if you want to test your NIC card in any device with IPv4, so in CMD command prompt, you have to type ping space loopback address. Like suppose 127.0.0.1, then 2, 3, 4, any IP address here, which start with the number 127 here, loopback address here. So suppose we have this one loopback address 127.0.0.1, and this ping is used to test the reachability, packet internet grouper. Okay. So device itself will test your NIC card status. So that's why this is called as a loopback, like this. Loopback address. So if you get a reply from this IP address, it means NIC card is working properly. There is no problem with this NIC card. If you are not getting the reply, it means NIC card is not working properly. So we know either by using ncpa.cpl also, we can check the status of NIC card here, or by using this IP address also, we can also check the status of NIC card. So you can see ping space loopback address 127, and this 127 network is already assigned to the devices here with particular operating system. So again, we cannot assign because this is already present inside this device here. So you will get a reply. It means NIC card is working properly. And in practical, we will discuss here these values here: 32 byte, RTT round trip time, TTL value, time to leave, 4 packets send, 4 packet receive, like this. But if you get a reply, it means NIC card is working properly. Same you can also check with second IP address here 127.0.0.2 here, you will get reply because entire network is reserved here 127 here. So that's why we cannot use here 0 network and 127. Any IP which start with the number 0 and 127, because these IP addresses are called as the reserved IP, or we can say special IP address in class A. So that's why valid range we have this 1 to 126. Any IP we can assign in between this range here to these devices, router, switch, PC, like this. This is the valid range. 0 to 127, this is the total range, but both are reserved here, 0 network and 127. Then suppose if you want to assign this IP address to these devices, so any number you can use. Suppose they are 10, for example, 10.1.2.7. So this is valid number here in between this range here, except 0 and 127 here in class A. But again, in class A, you will get private IP address. Out of this range here, we have to use actually private IP address. So next session, we will discuss what is private IP and public IP and how to identify this IP address also. But generally in local area network, we have to use only private IP address. So private IP means in each class, you will get some IP addresses are already reserved here. These are the private IP in class A, B, C. So we have this range for class A, 0 to 127 total range, but valid range 1 to 126, except 0 and 127 network. Then for class B, we have this range 128 to 191. But again, in this class B also, you will get private IP, but we have this one special IP address also, network, in class B. So if you want to assign here class B IP address to the devices here, so except this one network here, which is 169.254.0.0 here. So in this class B, you will get this one special network here, and the network ID here 169.254.0.0. It means any IP address which start with the number 169.254, because this 00 means network ID. So in next session, we will discuss how to calculate network ID, this network address and broadcast address. So that's why this IP address range, this is also special IP, reserved IP address in class B. So any idea what is the name for this range here, reserved IP in class B? Yes. Any idea what is the name for this IP address here? Network. So this is also reserved IP or special IP, because this IP address range is called as an APIPA IP, automatic private IP addressing, APIPA. So that's why this range is reserved for Windows operating system here, because APIPA is a feature of Windows operating system only, not for any other operating system. So if this device having Windows operating system, so in this device, this network is already assigned here for automatic assignment here. This is called as an automatic private IP addressing. It means this APIPA means here, suppose we have this one local area network. Then in this local area network, if you want to assign the IP address to this device, so either manually we can assign the IP address here, class ABC, any class here to this device. This is called as a static IP. Or the second type is dynamic IP. So can you tell me in dynamic IP, dynamic means automatic. So which server is used here? What is the service name actually for automatic
DHCP.
assignment of IP address? Correct. DHCP.
Yes.
So right. So we have to use a DHCP server here. And if you use a DHCP server, so DHCP server will automatically assign this IP address to all DHCP client here. So suppose we have this DHCP server, which is called as a dynamic host configuration protocol, DHCP server. So in this DHCP server, we have to add this network here, either class A, B, C, whatever of the network. Okay? So DHCP server will assign this IP address to all DHCP client here. These are not DHCP client here, okay? Because these are the networking device, and for networking device we require a configuration, initial configuration. So these host and the devices, these are the DHCP client. So each devices will get an IP address from DHCP server here automatically. If you add this network ID here, so this is called as a dynamic IP. But in case if DHCP server is failed, suppose, so these devices will not get any IP address from the DHCP server. So in that case, if this device is having only Windows operating system, so this device itself will assign automatic IP, which is called as their APIPA from class B. If this device having Windows operating system, so actually for same network communication here. So the IP address, suppose for example 169.254, and it can be any IP. Just only first two octet will be same here. 169.254. Then suppose here 1.40. Same, suppose this device having Windows operating system, so 169.254 not any IP address, suppose 2.70 or 2.10, whatever the IP address, okay? But only first two octet here. Same for this device. If this device having different operating system, so there is no APIPA. Okay? So in that case, we can take backup DHCP server, or manually we have to assign the IP address. Okay? Otherwise, if we have all Windows operating system devices here, so each device will take automatic IP. So that's why this is called as an automatic private IP addressing. APIPA is a feature of Windows operating system. So from class D, from class B, this special range is already reserved here. So this is called as a reserved IP or special IP address also. Special IP in class A, we have the 0 and 127. Special IP in class B, 169.254. Okay. So in dynamic IP address also, we will discuss about DHCP in details and APIPA again. Okay. If
Sorry,
DHCP
sir.
server is, yes.
Excuse me, sir. When we say APIPA, are you referring to one single IP or is it a range?
No, range here you can see. Actually, in this range here, 169, this is actually network ID. So 169.254, and in second and third octet, you can write any valid number. 0 to
Okay.
255.
Okay. Okay. Thank
So
you.
that's why the first, this is actually network ID. So first APIPA IP you will get here 169.254. We have to understand here octet format here. These are actually two octet, first two octet. Then in this last octet here, third and fourth, so first APIPA IP 0.1. Because 0.0, this is actually network ID. Okay. You cannot use. Then last IP address here. Okay. So in this range here, last IP you will get 169.254 here. So can you tell me what will be the last IP here in this one?
255.255.
But when you write here 255.255, okay, again 2 times here. Actually, this will become broadcast ID because we know broadcast ID is the last IP address here. So that's why for APIPA here, this is the first IP address here 0.1. Then you will get here 0.2, 0.3, 4, 5, 6. Number of IP address you will get here in this range here. Okay. Number of IP. So we will calculate this number of network and number of hosts also here. Okay. But in this one, the last IP you will get here 255 in third octet. Again in fourth octet here, if you write here 255, this will become actually broadcast address. Okay. So that's why valid IP you will get here 254. Because first IP you will get actually network ID here, this one 0.0.
So this
160.
broadcast ID applies to every class?
Yes, in each class you will get broadcast ID. Okay, so you can see this is actually network ID. So in next session we will discuss what is network address, broadcast address, and how to calculate this one. So if it is 00, then this is network ID, and broadcast ID you will get here 169.254.255.255. Actually, we cannot assign this IP address to any device here. Network ID and the broadcast ID. We have to use only this valid IP in each class, not only in class B. In class A, B, C, okay, you will get here network ID and the broadcast ID. Okay. So except these two IP, remaining IP addresses we can use in any class here. So that's why we have this valid APIPA address range here 0.1 to 255.254 here, because if it is 255, then this will become broadcast ID. Okay. So that's why we have this range here. Total IP you will get up to 255 here in this one, but this will be broadcast ID. Okay. So that's why automatically APIPA will assign any IP address here. You can see 2.10, suppose 1.40, whatever the IP address here. Okay. With this number 169.254. So that's why we cannot use here class B, this network here to the device. This is already used here for Windows operating system. But again in class B also you will get some private IP address, and in the local area network we have to use only private IP address. Okay. So in dynamic IP again we will discuss in details here what is APIPA, how DHCP works. Okay, DHCP server, DHCP client, DORA process, okay, all this one. This is just range here. Okay. Then in same in class C also you will get some special IP addresses are reserved like private IP. Okay. So in next session we will discuss what is private IP and public IP. Then remaining IP we can use, but generally in each class here, in class A, B, and C, we have to use only private IP address in the local area network. Okay. So this is only range calculation here. Then in IP address here, we have this next topic here, octet format. Because we know in IPv4 you will get total 4 octet here for each class here, but only for class ABC, not for D and E, because D is multicast here. So that's why octet format means IP address is divided into two portions. Any IP, either it is class A, B, C, like this. So any IP address is divided into two portions here. First portion represent a network portion. Then second portion represent a host portion. So host means actually devices. So that's why for class A, we have this octet format. Network, host, host, and host. Total 32-bit, but for class A, only one octet is reserved for the network portion. Single octet. And 3 octet here are reserved for host portion, for the devices. Then in class B, 2 octets are reserved for network portion, network, host, host. And 2 octets reserved for host portion for the devices. But in class C, 3 octet for network portion, network, and only 1 octet for host portion here. It means we have this class A octet format here. So for class A here, we have this octet format, default octet format. And there is no octet format for class D, because class D for multicast here. So for class A, you will get here network, host, and host. So we have this total 32 bit, but in class A you can see for network portion only 8 bit here, and for the devices here for the host portion total 24 bit here, because in each octet 8 bit here in the binary. So that's why total we have this 32 bit in IPv4 here. So that's why here network bit in class A is equals to 8 bit. Then host bit 24. Host bit 24 here. So it means if I write any class B IP address here, suppose we have this one IP address, for example 10.1.5.99, suppose, okay, we have this one IP address class A. So by default for class A you will get slash notation. Yes. So by default you will get slash notation here 8, and this is for our understanding 8 notation. So this slash 8 notation is called as Cisco slash notation, and this slash notation, this represent total number of network bit in this IP address. This one, this is called as slash notation. Number of network bit here 8. So that's why by default slash notation for class A IP address is 8. It means if you compare this IP address with this octet format, so this 10 portions represent their network.
Can you repeat?
And this 1.5.99, these are for devices.
Excuse
And
me,
this
sir.
slash 8 means this total number of network bit. It means in this IP address, right now this IP address is divided into two parts. The first part is network portion. So this is the network portion here, 10, first octet. This is nothing but network portion. So for all the devices, this network portion should be same. Okay? And we have this host portion, last 24 bit, 1.5.99, second, third, and fourth octet. So you can change here this portion, because these are for devices here. Host nothing but devices. So that's why this slash notation 8 means total number of network bits. So when you convert this 10 into binary, so you will get a binary bit 0, 0, 0, 0, 1, 0, 1, 0. Same for this next octet. So that's what this slash 8 means. Actually these are the binary bit. So these binary bits should be same for all the devices. Then all the devices are in the same network. And in decimal value, first octet should be same for all the devices. If you are assigning class A IP address to any device here, either in local area network or in wide area network here. It means suppose we have this device here in the local area network, we have this PC1, PC2, whatever we have this device here, router, PC, okay, switch. So network portion should be same here. So suppose we have this one IP address for the PC1. No need to assign the slash notation, because slash notation is for our understanding. Okay? There is actually subnet mask here. Okay? So in next session, we will discuss about subnet mask also. Then same for this PC2 here, first octet should be same. And if you want to write IP address in second, third, and fourth octet, you can write any number, because this is host here. So we can change your host portion device. Suppose here 10.200.1.9. Okay. Same for this PC3 here. First octet should be same 10.0.0.40. So you can see in these devices, first portion is already same for all the device, network portion. You cannot change your network portion because they are slash 8 notation. So that's why in the binary here, 8 bits are same here for all the devices. And in decimal number 10 here, first octet. So that's why all these devices are in the same network here. So that's why these devices can communicate with each other here, because network portion is same here by default slash 8 notation. You can change your second, third, and fourth octet here. In host portion, you can write any valid number here in between 0 to 255. But for class A, these network portion should be same here. And you can see for all the device, network portion is same. And in host portion, you can write any number, valid number. So that's why we have this octet format. It means in this IP address here, this is the network portion and these are the host portion. Then again this network portion, host portion, network portion and the host portion. So it means host portion you can change. Network portion will be same here. If you change a network portion, like suppose you have 20 for example, it means only these two devices are in the same network and this PC3 is present in the different network. So actually direct communication not possible. We require router device. Okay. But generally we have to select a same network here like this. So that's why for class A, first octet should be same here. So that's why we have this octet format for class A, default octet format. Same for class B also. You will get a default octet format here. So we have this next class here, class B. So in class B here, the octet format is network, network, host, and host here. Network, network, host, host. So we have this network bit in first octet 8, in second octet again 8 bit 16. Then host bit here 16. Then if I write this class B IP address, any IP address, suppose for example 172.20.1.8 here. So can you tell me what will be the by default slash notation for this class B?
/16.
/16, because slash notation it represents total number of network bit here. So that's why in class B, if you want to assign the IP address to the devices here, so 2 octets should be same here. So that's why we have this network bit 16 and host bit also 16 here. So total 32 bits here. So in this IP address, because this is class B 172, so first 2 octet should be same for all the devices here. Because right now, if you compare this IP address with this octet format, so this is the network portion and these are the hosts. So you can change your third and fourth octet in class B. So that's what these 170.20 first 2 octet. This is the network portion. So that's why for all the device, network portion should be same here. And this 1.8 third and fourth octet. Okay. This is for host here. So you can change. So that's why slash notation by default 16, which represent total number of network bit here. So same for this device here. We have this class B IP address. Suppose if you are using class B. So first 2 octets should be same here because slash notation is 16 here. Then in third and fourth octet, you can write any IP address, but valid number here in between 0 to 255. So if in class B, first 2 octets are same, 16 bit in the binary also, because when you convert 172.20, so 172 means you will get here 8 bit in the binary. This 20 also 8 bit, total 16 bit. So these 16 bits should be same here. Then in third and fourth octet, we can write any number. Suppose here 1.10, okay? Then here 20.4, whatever we have this IP address here, then 7.98 like this. So that's why all these devices having same network portion here, okay? Because their network portion is same. It means all these devices are in the same network, so communication possible here. Because in host portion we can write any number here, okay? Valid number. Same for class C also. Okay. But here by default slash notation for class A /8 here, and for class B /16. But suppose if you change here slash notation, for example, instead of this 16, if you find here for example 19 or any other number up to 32, so right now we have this 19, it means this is not a class B IP address because network portion is changed. So right now 19 bit represent network portion here, and this is the concept of subnetting. This is called as actually subnetting is performed here, and this IP address is called as classless IP. If you find any slash notation except default slash notation, because you can see right now this is not a network portion because total 19 bit in the binary represent network portion, 8 bit 8 bit, and when you convert this 1 into binary, again you will get your first 3 bit. So these are the 19 bit here, and remaining 13 bit represent host portion. It means this is called as subnetting. Network portion is changed. So classless IP address, if it is not by default. So that's why this is called as actually subnetting. So in subnetting, we will discuss here what is subnetting, Okay, because subnetting is most important topic here. Logical division, FLSM, VLSM calculation like this. So for class B, by default slash notation should be 16. If it is any number except 16 here, like suppose 1, 2, 3, okay, less than 16 or greater than 16, up to 32. In between slash 1 to slash 32, except 16 here. If it is any slash notation, so classless IP. If it is 16, then class B. Because network portion will be changed after subnetting and IP address will become classless. Same in class A IP address also. If it is by default slash notation 8, but if you change here and if you write any slash notation, suppose for example here 12. So right now this is not a network portion because only 8 bit, but right now 12 bit represent network. So 4 bits are also converted here. Network portion is changed and this IP address is called again classless IP. This is not a class A IP address because network portion is changed. So for class A, by default slash notation should be 8, first octet. If it is any slash notation for class A also except 8, classless IP. Okay? It means subnetting is performed there. Same for class C also. We have this octet format here. Okay? So that's why here for class A, we have this by default slash notation 8. If it is any slash notation, slash 1 to slash 32, classless IP. Okay? In class A, B also. Then for class C also, we have this by default octet format here. So the last one is class C here. And we have this octet format for class C, network, 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 and host. So we have this one class C IP address here, 192.168.1. Suppose 4. So what will be the by default slash notation for class C?
24.
24. It means this 24 represent network portion, means network bit actually. By default here without subnetting. Actually, we are not talking about here subnetting. Subnetting is different concept here. This is just by default here. Okay. So that's why this 8 bit, 8 bit, 8 bit, 24. And for the host, only 8 bit. So that's why after this, in next session, we will discuss how to calculate number of network and number of hosts also. So actually in class C, you will get more number of network than A and B, but you can connect less number of devices because of this last octet here. Only one octet for host here. So that's why network bit 24, host bit 8, total 32. So in this IP address, first 3 octet here, network, network, network. This is the network portion. And the last octet here, you can add any number. Okay? So this is host portion, but actually valid number here. This is host. So that's why this is by default. Same if you change that slash notation, suppose 29. This is not a class C IP, classless IP. If you find any slash notation except 24, because 24 is by default. So that's why we have this network portion. And for all the devices here, first 3 octet should be same. If you are assigning here class C IP address here, this is by default here, slash notation 24 here. So that's where suppose 192.168.1 network portion. Same for PC2 also, 3 octet here, and same for PC3 also like this. And just you can change your last octet and you can add any valid number here. Suppose they are 1.5, 1.10, 1.200 like this. Because they are slash notation, this is the network portion. Slash notation 24. So all these devices are in the same network here. So that's why communication possible. Because network portion is same. Because of this octet format. So that's why this octet format is used in IP address here. IPv4. So that's why when you configure this LAN configuration, means initial configuration, WAN configuration. So in this configuration, you will get here same network portion here. Either it is class A, B, C like this. So in this WAN connectivity here, we have this different networks here, you can see. So for Chennai branch here, we have this router IP. So you can see for the devices, this is class C actually. So 3 octet should be same here. And you can see 3 octet here, 192 .168.201. First 3 octet. So that's why this is actually network ID. 3 octet should be same here. And in last octet, you can see .1 and here .10. Last octet here. Okay. So that's why this is class C. First 3 octets should be same. And we have this class B IP address here. Any class we can select. So you can see for this class B, only 2 octets should be same here. 173.16, 173.16. And you can change your third and fourth octet. You can add any number here because only 2 octet here, network, okay, for class B. If you are using class A, so only first octet should be same here by default. Okay. So that's why in IP address, IP before, octet format is used here to divide IP address in two parts, network and the host. So that's why depending on this octet format, you will get number of network and number of hosts for class A, B, C. Okay. So in next session here, we will discuss how to calculate number of network and number of hosts here for class ABC and how to assign the IP address, subnet mask, private IP, public IP concept, and the last one, assignment of IP address, static and dynamic IP here. Okay. These are the remaining topic here. So you can join the WhatsApp group here. So ping me on this number on WhatsApp here, write your name and batch timing. Okay. So you can join the WhatsApp group here. Okay. So any doubt in this topic here as we discuss IPv4, because IP address is most important concept here, because in each configuration we have to use this IP address, class A IP, class B, class C, like this. In initial configuration, WAN configuration, we have to use only IP address here. Okay. So in this IP address here, IPv4, remaining topic we will discuss in next session here. Okay. Okay. Bye all of you.
Bye, sir. Good.
Bye, sir. Thank you very much.
Thank you, sir.